Now that we have a better understanding of this idea of a range of values and how to interpret that range in context of the story, I want to take a step back and look at how we actually calculate those values and the formula for that. So the goal of a confidence interval is to find a range of values that contain the true population mean mu, or if you were working with categorical data, you would be looking at the population proportion. So you can make confidence intervals for a variety of different things. In this class, we're going to stick with means because those are the easiest to work with, at least in my opinion. All right, so to calculate the endpoints of this range of values, we're going to look at it a little bit differently. So rather than saying from the min to the max, the formula is set up so that that interval is always centered at your sample mean. And then there's kind of a little bit of a fudge factor on either side of it. So we'll have that point estimate, our sample mean, and then it'll be plus or minus something. So you've probably seen something like this before in politics, where they'll say something like 68% of the people surveyed were in favor of this new bill, and it had a margin of error of 3%. So what that really means is that they think somewhere between 65 and 71% of people are in favor of that legislation. So that's how we're getting from our sample mean to this range of values. Okay, so to do this, we're going to first need a point estimate, and that's going to be our sample mean X bar. And then to get that like plus or minus 3%, we call that part the margin of error. We're going to need sigma, our population standard deviation, and n, our sample size. So those two you should be really familiar with at this point. And then we're also going to need z star. So z star is the z-score that's tied to the confidence level. And we're going to look at that in just the next slide, so hang tight. The formula for this is going to look like your estimate, so your sample mean X bar, plus or minus your margin of error. So that margin of error is z star times sigma over the square root of n. So that sigma over the square root of n should look really familiar from chapter 15 with those sampling distributions. That was how we found that standard deviation for the sampling distribution. And now you can see that show up again here in confidence intervals, and you'll see it again in the hypothesis test. So our confidence level is, in books they use the capital letter C. You'll probably never see that in any of the problems, but for clarity, that's what they're using there. That confidence level gives the probability that the interval will capture the true parameter value if we repeat this process many times. I know that sounds like a lot of words, and we're going to come back and look at that again at the end of this chapter, and it'll make a lot more sense then. So to calculate Z star, what you're going to do is you'll take 100% because that's the total area under the curve, and you'll subtract off that confidence level. So if it was a 90% confidence level, I'd do 100 minus 90%, and then I would divide that by 2, and then I can look up the z-score attached to that probability. So there are 3 that are most commonly used, and that is the 90%, 95%, and the 99%. And I've provided those z-star values for you. So you could actually put this in Rossman Chance and get the z-score yourself. But these are the most commonly used ones. So I put those down on your paper and keep that handy. So if we're using a 90% confidence level, our z-star will be 1.645. If we use a 95%, we're going to have 1.96 for z-star. And then 99% is 2.576. So the higher that percentage, kind of the wider that interval is. You see how those numbers get bigger, it's going to increase the size of your interval. All right, so come back in the next video and we'll take a look at how to actually use that formula and calculate these values.